Welcome to This Explainer. Today, we're diving headfirst into Professor Cornel Stans' totally data-driven analysis of global climate policies, EVs, and alternative energy. You know, this analysis really flips the script on what we hear in the daily news cycle. It gives us a highly structured, nuts-and-bolts look at the actual physics and economics behind our global energy transition. Let's get into it.
Okay, let's kick things off with this incredibly provocative core argument from our source material. It directly challenges the whole one-size-fits-all ban on internal combustion engines. This quote literally sets the foundation for everything we're about to unpack. Professor Stan is arguing for a massive paradigm shift here. The machine itself isn't the enemy. The fossil fuel is. Make sense? Let's keep going.
To truly wrap our heads around this complex topic, we're going to quickly walk through the four main pieces of the puzzle. First, the decarbonization mandate. Then, the global energy reality. Third, the electric vehicle dilemma. And finally, we'll break down climate-friendly fuels.
All right, starting right off with Section 1, the decarbonization mandate, where we'll look at current climate goals and policy shifts.
So, you've probably heard of the European Union's Fit for 55 package, right? Well, this legislation mandates a massive, and I mean massive, 55% reduction in CO2 emissions by 2030 compared to 1990 levels. The ultimate goal? Total greenhouse gas neutrality by 2050. That is a monumental target. It essentially demands that carbon be drastically slashed across literally all sectors of society in just a few short years. And this brilliant visual perfectly illustrates exactly why these targets exist in the first place. Anthropogenic carbon dioxide, that's the carbon from burning fossil fuels, is steadily bumping up the atmosphere's temperature by trapping reflected solar radiation. Now, a natural greenhouse effect is great. It keeps our planet from freezing solid at minus 18 degrees Celsius. But the excess CO2 we've pumped into the air since the Industrial Revolution, well, it acts like a constantly thickening glass roof. And that's what's causing the dangerous temperature spikes we're seeing today. To fight back against this thickening glass roof, the EU has proposed some incredibly aggressive legislative amendments. The big one, decreeing that from 2035 onwards, all newly registered vehicles in the EU must not emit CO2. Boom! They are effectively mandating battery electric cars. On top of that, they're rolling out stricter emissions trading and carbon border adjustments. It's basically a massive push to force both domestic and international industries into complying with these huge decarbonization goals. But as we move into Section 2, the global energy reality, which looks at fossil fuels versus renewable growth, we hit a pretty massive snag. What works in Europe doesn't necessarily map to the rest of the globe. To really grasp the scale of this global bottleneck, we first need to get our definitions straight. We have to understand the difference between primary energy, those raw, unrefined sources of power like coal or raw sunlight, and final energy, which is the actual electricity that reaches the sockets in our homes and charges our cars. This distinction is absolutely crucial, because transforming raw primary energy into usable final energy always involves conversion and transportation losses.
Now, take a look at this. What's truly fascinating here is that, despite all the hype and growth of renewables, our global primary energy mix is still overwhelmingly dominated by fossil fuels. Just look at the sheer volume of coal, oil, and gas compared to those tiny slivers of renewable energy sitting at the very top. The hard truth, the global appetite for primary energy just continues to climb year after year. To put some hard numbers on it, a staggering 84.3% of global primary energy currently comes from fossil fuels. Compare that to just 2.2% from wind and a mere 1.1% from solar power. I mean, it's wild to think about, right? We hear so much about the massive expansion of wind and solar, but their actual current contribution to keeping the globe running, it's still just a fraction of the total pie. Make no mistake, we are still firmly planted in the fossil fuel era.
And it gets even more complicated when we zero in on oil consumption specifically. Nations in Asia alone consume 63% of the world's oil. They heavily rely on these exact fuels to power their rapidly expanding industries and massive megacities. And here's the kicker, despite only producing about 14% of the world's oil themselves, these Asian economies are the primary drivers of consumption. It highlights an immense, deeply entrenched global dependency that you just can't switch off overnight.
And that deep reliance on fossil fuels sets the stage perfectly for Section 3, the electric vehicle dilemma. Because we really have to ask, where does the electricity actually come from?
We hear all the time that electric vehicles are the ultimate zero-emission solution. And locally, sure, they are. But the broader data reveals a totally different story. The electricity actually powering those cars is often generated by highly polluting sources, and it depends entirely on what country you're in.
Think about it this way. When an EV drives down the street, it has no exhaust pipe, right? But that exhaust pipe hasn't disappeared. It's simply been relocated to the power plant that charged its battery.
So the crucial point here is comparing regional energy grids. An electric car driving in Norway is incredibly clean, thanks to their massive use of hydropower. But take that exact same car and put it in India or China. Suddenly, it is largely running on coal-generated electricity. Mandating electric vehicles in countries without a green electrical grid completely defeats the global purpose of decarbonization. It's like putting a Band-Aid on a broken leg.
To really put that into perspective, let's look at China, which happens to be the world's largest manufacturer and consumer of electric cars. They currently operate 1,077 coal-fired power plants, and they are adding up to 30 new ones every single year. So, the more electric vehicles that hit the road in China, the more demand there is for electricity, which right now literally requires burning even more coal.
And this brilliantly illustrates the core paradox we're facing right now. If we abruptly switch all vehicles to electric without fundamentally changing the primary energy source first, we aren't solving the problem. We merely shift the pollution from the streets straight up into the global atmosphere. Sure, the local air in the city gets cleaner, which is a huge, wonderful health benefit for the people living there. But the overall planetary climate problem, it actually gets worse.
So what do? Let's move to Section 4, Climate-Friendly Fuels Explained, and explore some alternative paths to decarbonization.
Here's the million-dollar question. If replacing billions of combustion engines globally with coal-powered electric batteries isn't the ultimate climate fix we thought it was, what on earth is the alternative? How exactly do we decarbonize massive regions of the world that simply do not have pristine renewable power grids yet?
Well, the author argues that we shouldn't throw the baby out with the bathwater. We should keep the highly efficient combustion engine, but totally change the fuel. We're talking about utilizing climate-friendly alternatives, like green hydrogen, methanol, ethanol, and hydrogenated vegetable oils. The beauty of these? They are drop-in solutions, meaning they can be used in the internal combustion engines we already have right now.
Let's walk through this incredible process because it's a real game changer. Instead of dealing with absurdly heavy batteries and massively expensive electrical grid upgrades all over the world, we can actually capture surplus solar and wind energy in remote areas, convert it into green hydrogen or synthetic fuels, and then just transport it globally using the infrastructure we already have. You take renewable energy, use it to separate hydrogen from water, synthesize it if you need to, and boom, you have a highly efficient liquid or gas fuel. Now, what's really fascinating here is the concept of a closed carbon loop. This literally means a traditional engine can operate with a net zero carbon footprint. How? Because it simply recycles the carbon dioxide that is already present in the natural environment. When it burns, it only releases the exact amount of carbon that it originally took out of the air to create the fuel in the first place. It's brilliant.
Which leaves us with this absolutely crucial question to ponder. Rather than forcing a one-size-fits-all ban, is a diverse, mixed technology approach actually the most realistic way to save our planet's climate? Relying on EVs where the power grids are already green, and using climate-friendly alternative fuels literally everywhere else might just be the pragmatic, data-driven path forward we desperately need. Thank you so much for joining me for this explainer. Keep questioning the data, keep learning, and I'll catch you next time.